Michela. She's gonna talk about how to earn $160,000 a year. I don't know how to do that, so I'm very keen to learn how to do that. Please welcome Michela.
And in 15 minutes. Can you imagine? When Julio gave me this mission, I concluded that it was a mission impossible, but that's what we say, let's go for it. So first a little bit about me. My bachelor degree is in mathematics in São Paulo. I also did an executive MBA and machine learning specialization. That's an online course, okay? When I started working, I was hired as a data scientist at Banco Pan-Americano in Brazil, and I would like to show you something. That's my, as you know, my carteira de trabalho. And this is, well, after 1 year as a data scientist, they decided to find a name for my position that they choose analista de escoragem pleno. This is because I was trained in credit scoring models. And escoragem in Portuguese, as you know, it's like to hold something to. So there's nothing related to scoring, but as you know, the profession, nothing related to. There was not even a name for this profession yet. So that was the bad translation that they found too. Anyway, as you know now, the profession is old. It's not that new as we all think sometimes. They've been changing the name over time, but now the new name is data scientist, but it's not that new. And apart from my SAS, R, and a little bit of Python skills, I'm also a kite surfer and a beekeeper, amateur beekeeper. I'd like to let you know that. If you want to talk about kite surfing or about honeybees, I'll be more than happy to talk to you about it. And if I can press twice. So why the boom of data scientists? Why this happened lately? This is what happened lately. So one reason is that back in 1956, the way to storage data was really difficult. How do we storage data back in 56? So to store 4 or 5 megabytes of data, the size of the device was the same size of 2 refrigerators. So can you imagine that? Like 2 refrigerators to store 1 picture. That's the size. And then this improved a lot. So back in, let's say, 2001, the first pen drives, our pen drives could store 8 megabytes, and that was this size, and 8 megabytes of data. So now we can store 2 pictures. But at least it's this size. And now we have exabytes of data that, like 2013, that could be stored in the cloud. And this is something like, I don't even know how many zeros we have in 1 exabyte. But it's a lot of data. And the price also decreased a lot. The price to store 1 megabyte, can you imagine that when it was the size of 2 refrigerators, and now to store gigabytes of data is peanuts, cost peanuts. So you can, this is one of the reasons, this evolution. Another one is, this is a clock. Unfortunately, I don't know what happened with the clock, but here we had the years, and this was since 1950s until now, 2018. This is a plot with the average of, let's say, the power of a computer, the processing power of a computer over time. So this is in terms of number of transistors. That's one way only to calculate the power. So can you imagine like what happened in the last, let's say, 10 years? It's incredible what happened in the last 10 years in terms of power of processing. And then, remember when I started that job as a data scientist back in the 90s, late 90s? When we had to buy a software to train the statistical models, we had two options, SAS and SPSS. Two options. Now, that's what we have. This is just part of the market. And we have more than that. We also have open source. So, open source is not that new, but now it's very popular because of the processing power of laptops, plus the way to store data that's very easy, and then easy to install. We also have even in the cloud, Amazon, for example. So that's the reason why the boom of the profession, data scientists, started. And now we have all these buzzwords. Machine learning, artificial intelligence, that probably some of you already heard, deep learning, data science, advanced analytics, and so on. And what is happening? What this means is that we don't know exactly what is what. And I'm going to tell you there is no consensus. I cannot tell you that I'm here to tell you what is what, because there is no consensus about that. What I can tell you is that, for example, this is an oversimplified definition, that data science produces insights, machine learning produces predictions, artificial intelligence produces actions. I don't even agree a lot with that, because I was a data scientist and I used to produce predictions. To predict if a customer would pay, to predict if a customer would buy, to predict if a customer would be profitable. And I was a data scientist. So there is no consensus. We have another explanation that I find much better, that says that artificial intelligence, it's exactly what it sounds. It's the idea of electronics trying to resemble human intelligence in some way. And then some people start thinking, but what is intelligence? And then someone came up with an answer. Intelligence is the ability to learn. So then they decided that if it's the ability to learn, let's talk about machine learning. That's how came this term, machine learning. And then we start talking about a list of algorithms and models that are designed to leverage computing power to improve the process of learning from data. Then others came with the term predictive analytics, because then we'll use all these algorithms, all this data to predict something. So let's predict the future, not like those fortune tellers that come and read your hand, more like using data. And then big data. What is big? Big. I used to work, when I was working at SAS in Brazil, I had some projects at Petrobras, and they always thought in the beginning of buzzword of big data, they always thought that they had big data. So they used to call SAS to say, look, come here, because we have a big data project. Then I used to go there and start talking about big data. And they said, look, this is really big, the data. And it would fit in a pen drive. Like then, it would always fit in a pen drive. So, but there is one thing that I believe it's consensus about all these buzzwords and data scientists, and it's a combination of maths and statistics, computer science and data, okay? That's I think it's a consensus for all of these explanations of what all these buzzwords are. So how to get there, how to become a data scientist. When we talk about maths and statistics, let me tell you guys, you need to have a solid statistical knowledge to become a proficient data scientist. A proficient data scientist has a lot of statistical knowledge and mathematics. You have to like that part, okay? This is one book, and that you can read. It's a very good book. I have a good story about this book. In my first interview in Australia, the person who was trying to hire me, or in fact that I was trying to be hired, and he asked me to read this book, and he said, it's a small book, around 100 pages, and then I went back home, and my boyfriend had the book at home because he's also a mathematician, and I got the book very happy. And well, first of all, the book had 400 pages, not 100. Second, it's not like reading caras. It's reading a very yeah. And the guy gave me 2 weeks to read the book, and let me tell you, it was tough. I had to read every day, and then I got the job almost. It was almost a miracle, but that's a very good start, because it's not just a book about statistics, but it's about statistics using R. So I find a very good start. Computer science, my tips would be learn R and learn Python. I listed here some of the main libraries or packages that data scientists use. That's definitely not a definitive list. There are many, many more, but this is a good start. And R is very used in statistics, algorithms, and the statistical part, and Python is used overall for everything. And then we have a list of programming language. This comes from a survey. That's the 2017 Data Science Salary Survey. And this is a list of programming languages that that data scientists use currently. And this is the percentage of data scientists that pointed out that they use. And that's the average salary, the median salary, and actually is the range salary without the first and the last quartiles. That's the 50%. And I'm showing SQL, but the data scientists, they do not use that much SQL. It's because this survey, there are some people that are also data engineers and also C-level managers. So data scientists, most of them, they use more R and Python. And in terms of machine learning, for example, this course is a Python package. And so that's what we are talking here. Python and R are the main programs, and they are both open source. And if you are really serious about it, go to this website. Everything is free, all open source. It's a full data science course. It will take, if you really dedicate, it will take you several months to complete. But at the end of this, so there are more than 10 books and lots of online courses. But at the end, I can guarantee that you are ready to start any data science, any job, at least to apply for positions and to do a good job in the interview, even without experience. If you go through this whole course, I think, and understand what you read, of course. So, what else? I think it's really important to talk here about communication skills. This is one thing that data scientists, they need. And about causality, because lots of people think that correlation, the data scientists are looking for correlation. They are not. They're not looking for correlations. This is one thing that we look, but we really have to understand the cause. Because if I see a plot like that and say Japanese passenger cars sold in the US correlated in more than 93% with suicides by crashing of motor vehicle, do you think if I recommend to the US stop buying Japanese passenger cars because you reduce the rate of suicide? This is not going to happen. Okay, so they are not looking for correlations only. They are trying to understand the cause. That's really difficult, Julio. This part is more difficult than the...
Wanna go back one?
No. Go ahead. One more. So another thing is, let's not forget that when we see some data there, usually it's about a person. We cannot dehumanize the data. So it's really, really important, and it's a new area of analysis to talk about data ethics. And this is something that's coming. I think the two main things that you'll see soon about data scientists is ethics and causality. So if you want to be like better than the average data scientists that are in the market currently, go for not only understanding all of the R and Python and the statistical algorithms, try to study a little bit of causality and data ethics. That will do an even better job in interviews. And when I talk about communication, this is a list of the tasks and responsibilities that all the data scientists answer in that survey. So as you can see, communicate findings to business decision makers is the third. So all the rest are the obvious ones that you know. And they also asked me to talk a little bit between the difference of a data engineer and a data scientist. So here in blue, this side is the data engineer. It's much more about the organizing and developing data process to help or to prepare the land to the data scientist to work most of the time, to have access to the data, to help to clean the data, to put the data in a good format, and afterwards, the way back, to help to deploy the models that the data scientists train, to help to deploy the models back in production, okay? So languages, tools, and softwares, I will repeat some of them, but also between the difference between a data engineer and a data scientist, here you have to keep R and also Python, that are the main ones for data scientists. And data engineers, they also use a lot of Python and R. And they also have been using a lot of like Spark and working with Hadoop. And so this part is more the focus of data engineers, okay? We can pass this one. Next. So, some key takeaways. Talking about the things that Julio asked me to talk. Artificial intelligence versus machine learning versus predictive analytics. There is no consensus, but guys, it doesn't matter. Read a little bit about to understand what is what, but it's not a big deal because nobody knows exactly what are the main differences. If you like maths, statistics, and you want to become a data scientist, start by the open source data science masters, that link that I gave. That's a very good start, okay? There are meetups, and I put 2 meetups. That's the way I found my first job as a data scientist here in Australia. I went to one of these meetups and I met some people there that were looking for data scientists. So go to the meetups, they are free. This is all free. And then you get to know people who are already in the market. Coursera and Udemy are very, very good start for online courses. If you feel like you're not that good at self-studying by yourself at home, go to online courses. Like today I checked Udemy, there were several, because of the Black Friday, there were several courses that were $200 for $13. So if $13, if you want to try $13 to do 1 or 2 courses, that's nothing. Okay, 1 beer and 1 burger that will have beer probably costs more than that. So just to try if you like. And Stack Overflow is a great place when you are coding. Stack Overflow is a great place to use for help. Go there and you get lots of help from people all over the world on how to code several things. If you do not like maths and statistics, better to go for a data engineer or a business analyst role. Try it, because that's really important. Data scientists need to like maths and statistics. That's one of the main parts. Okay? So that's it. I don't know if you have time. Probably not. Yeah? Questions?
No one?
Questions? No one?
No, Carlos, no? Alright. Yes. No one uses Rascal. No one.
Someone? Nope. No questions? Okay, you can always just, find Michela around. She's gonna be here having beer, so just find her. Thanks again.
Bye.